In college algebra, we practiced more with rational expressions. We left off having done 3a. Let's do 3b. So remember, we're factoring if possible, and then we cross out factors that are above and below that match. So the question is, can we factor the other three spots? This spot right here, that's as low as it goes. You can't factor that any. There's no x squared, no GCF. But right below it, that's the difference of two squares. That becomes x plus 3, x minus 3. Top right, we need two numbers that multiply to -6 but add to -1. So x minus 3, x plus 2. Right below it, two numbers that multiply to 9 but add to 6, x plus 3, x plus 3. All right, now we're going to cross out factors that are above and below that match. So, for example, x plus 3 and x plus 3 cancel. X minus 3, x minus 3 cancel. And there are no other matches above and below. So now we write our final answer. I'm okay with you just writing the leftover factors as they are. If you want to write it a little bit more concisely, you could write it like this. Or if you just really want to write it simplified, you would refoil out that bottom part, and this would be the simplified answer. But any of those three are acceptable, no problem. All right, part C. We once again need to factor, but this time we have division. So remember, let's look at an old fraction problem that you maybe had back in middle school. I don't think it was elementary. So if we have something like this, divided by 8/25, how do you do that? You keep the first fraction as is, you multiply, and flip the second fraction. And then you cross-cancel if possible. So 5 goes into 5 once, 5 goes into 25 5 times. 2 goes into 2 once, 2 goes into 8 4 times, and our answer on that would be 5/4. Let's try out the algebra one. I'm going to hold off on factoring until the next step. So you keep this one as it is, flip to multiply, and you flip the second fraction. Now factor, and we need two numbers that multiply to -8 but add up to -2. Difference of two squares. Hopefully you're a master of that by now. And the second fraction, there's nothing to be done. No x squareds, no GCFs. All right. I see an x minus 4. I see an x plus 3. And we're done. So final answer, x plus 2 over x minus 3. All right, we started another handout, just as more practice, especially with domain. So you see up here in the instructions, we are looking for domain. Remember on the previous handout, this isn't asking you to simplify. This is asking you to find numbers that would make this thing undefined or unsolvable. So it's pretty easy right here to know what you shouldn't plug into there. But if you don't see it, follow my steps. Yesterday I said set the denominator equal to 0. solve it, and that is the number that we don't want to ever plug into this function, to this expression. So the domain is any real number except -9. Number 2 is really different. So let's still do step 1. I'm going to give myself more room and work up here. So there's our denominator. Set it equal to 0. And when you go to solve it, you can't solve it like we did the last problem or like we did yesterday. You probably did this back in Algebra 2. If you move this 45 to the other side, you're stuck because of this term. You can't square root both sides. So what you do is you factor it, and then you set each factor equal to 0 and solve. So, for example, two numbers that multiply to -45 but add to 4 are 9, try to better 9, and -5. Now, looking at that, if I was to plug in -9, I would get 0, and that would give us 0 in the denominator. That would be really bad. So that's why when you do it this way, you get -9. Same with this. I don't want to plug in +5 because that's what will give us 0. So for our domain, we say x cannot equal -9 or 5. All right, let's try some more. So this time, it wants both things. It wants you to simplify and find the domain. So first off, let's factor if possible. So let's take out a 4 up top. On the bottom, looks like -2, -2. And we can cross out x minus 2. So simplified form is 4 over x minus 2. For the domain, you want to take the original denominator and set it equal to 0. The original denominator. So that means x squared minus 4x plus 4 equals 0. Now we already factored it. I already showed you how to do that. So I'm just going to copy what I already did on the left over there. And then this is pretty easy. They're duplicates, so you really only need to set one of them equal to 0, and you get 2. So the domain is any number except 2. Let's try this type of problem again. So number 4, I encourage you to hit pause and see if you can factor it and find the domain. But factored, we get x minus 7 over x plus 7 x minus 7. We cancel, and we end up with x minus 7 x plus 7 for an answer. Now we need to do the domain, and this is the scenario where you would run into a problem if you only look at this denominator. You have to look at the original typed denominator. So we go x squared minus 49 equals 0, which means x plus 7, x minus 7 equals 0. Set both equal to 0. And and we see there are two numbers we need to exclude from the domain. Positive 7 and negative 7. All right. We did one other problem today. We skipped number 5, and we jumped to number 6. So number 6 and 7 are totally different. We're adding and subtracting fractions. And remember back when you had a fraction problem like this? You need a common denominator. And one trick to doing that is to just multiply by the other fraction's denominator. So for example, 7 and 7, and the other fraction's denominator is 5. And that'll give you a common denominator. You get 14 35ths plus 5 35ths. Don't actually add the denominators, and you get the answer. Same concept here on number 6. I need a common denominator, so I'm going to multiply the other denominator times the fraction I'm looking at. So for example, x minus 3 times the first fraction. And then for the second fraction, I'm going to multiply by x minus 2. It is the same exact concept as what you see at the top of the screen, top right. Now you got to simplify. So we get this. You don't really have to write this step, but some people need it. So feel free to write it if you need to. Now we have a common denominator. I can add the tops. We have one giant fraction. Now you're welcome to distribute the bottom, but I'm wondering if up top, when we add like terms, maybe we could factor it and cross a factor out. So let's see. And if you're clever with your factoring, you can see we're not going to be able to cross anything out. But keep going. We're not simplified yet. Hopefully now you really see we're not going to gain anything by factoring the top. But you're welcome to try. Take a 2 out. And you get this. And now, obviously, I can't cross anything out. There are no duplicates. This was our final answer. If you decide to FOIL out x minus 3 times x minus 2, that's a-okay. I'll even take this answer. I'm more worried about the common denominator part and you simplifying. So that was as far as we went on Tuesday. See you later. Bye.